Hello, welcome to Zigmatech Learning Hub. I will be your instructor for physics. For this class, we are going to be taking our exercises from Examguide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, JCE, KCPE, IJMB, JUPEB, KCPE, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell and get updated on new videos. Are you ready for this class? Okay, let's get started. Welcome to physics class, and today we are going to look at the heat energy. When we talk about heat energy or simply thermal energy, even in this class, we have done series of videos on heat capacity and linear expansivity and all of them. But now we also want to talk about another kind of heat energy. Now, when we talk about heat energy, remember we are talking about thermal physics, a branch of physics that is called thermal physics, energy of heat. Now, heat energy, the study of heat energy, or what we call like thermodynamics, it has really helped a lot in the production of AC and so many other appliances we use at home. Let's get started to learn more about heat energy. By the end of this class, you should be able to state the effect of heat, what heat does to the body and what heat does to any kind of substance you see. And number two, you have to explain the kinetic theory of heat, the kinetic molecular theory of heat, how heat is affected by its kinetic energy. And then we talk about the kinetic theory or kinetic explanation of temperature. That is explaining temperature in terms of kinetic theory. If you are ready for this class, let's get it on. Now, there are different effects of heat that we have learned in our schools. We say that heat changes in temperature, and then we also say that heat changes the state of a substance or state of matter. Then we talk about the expansion. So heat causes expansion of objects. Then there are a few exceptions, especially when it comes to water. We talk about water has an anomalous behavior, but that does not mean that heat does not expand. Heat also expands water, but to a certain temperature, at least a 4 degrees Celsius, when water starts misbehaving and then start expanding when they are contrasting. And that also affect their freezing point and also melting point if the pressure is considered. Then we also say that change in the physical property, heat changes the physical property of a substance or object. We now talk about this great important branch of physics, which is called thermionic emission. We talk about thermionic emission because heat leads to the emission of some electronic substances from the metal surface. We also talk about the change in pressure. Now, let's look at them one after the other. When we talk about thermionic emission, we are talking about a metal substance such that when heated, sorry, let's go back. Look at this. This is a metal substance which is called hot filament with this coil. When it is red hot, very red hot, what happens is that they emit electrons. Then electrons leave the surface of the metal and then escape. Then that escaped electron can be used in different applications in physics, like we are going to be looking at, like the cathode, like the semiconductors, when we talk about the diode and all stuff. But then when we really concentrating on this one is we are limiting our range of explanation to what we have in this lesson, because this is a very full topic of its own in physics. However, the electrons emitted like this now, look at this hot filament, in a very high potential difference, then electrical energy converting to heat energy, and then that metal inside that coil, this coil you are seeing, they are all metal. Like this one is just a metal. Now when it gets to this point, it gets red hot, because remember that electricity produces heat energy too, because remember we said that energy can neither destroyed but not created, but converted from one form to the other. So the electrical energy gets to heat. Now when the metal is heated, they emit electrons from the surface, and that process of doing it is called thermionic emission. That means thermo, which is heat, and emission taken away. Then look at it also. This is also another way of seeing it. These are different ways where you can say that X-ray is produced and some other radiation, because energy was given to a metal surface, and the electron which are held by that metal surface was able to be emitted, and it is taken in different branches, like the X-ray, like I talked about, and even it goes further to the one they talk about, photon, but that is not thermal. This one is heat, not photo. Now let's move on. We also talk about expansion. Heat causes expansion. Remember what we are learning? We are talking about the effect of heat, what heat does. So what heat does is so important that they are applied in different areas in physics now, or even in real life. Look at this expansion. Like if you look at our video on linear expansivity or linear expansion, you realize that when heat is applied on a metal substance, it is metal substance, what happens? It increases in length. Some increase in area, some increase in volume, and that increment can be applied in different areas, which we have said, like the wheel, the balance wheel of a clock, the safety gap of the bridge. So when you are building a bridge, when construction, the people in construction companies, when they are working on roads, they consider those safety gaps, because different metals have different expansions, or linear, or coefficient of expansion, or linear expansivity. Like this one, if you look at this one, you realize that this is fine ceramics or alumina. Now look at the way it expands. The expansion is very small compared to the stainless steel, which has a higher expansion when heat of the same quantity is applied. So when you apply the same quantity of heat, some metals expand more, while some don't expand as much. So now, even the collapse of building, there are some metals you use for building. If you don't give space for such expansion, and when they expand, they're really going to pull the building, and that is what leads to the breach and collapse of many buildings. So heat causes expansion of many substances. Now, heat also causes change of state. You know what I mean by change of state? Sometimes when you put your water in the freezer, after some time, it blocks, it turns to solid, and that means the water has changed from the liquid state to solid state, and which is called freezing or solidifying. And also sometimes when you start boiling water, and if you leave the water on fire for a long time, or in a heat for a long time, the water can dry up from the pot. What happens? It has changed from liquid to gaseous form. All these things are what heat does, because heat changes the state. The state of a matter or a substance is the state it is at a given time. Could be in solid, could be in liquid, could be in gaseous form. We don't want to talk about the plasma, because probably beyond the scope of this class. But that is another set of states of matter which is not very conversant in this modern time. It's very conversant in this modern time, which wasn't there for some time ago, which we call plasma. But that would be in a different class. Now, looking at what you are having here, this is a gaseous state. Remember, there are two arrows. This is the first arrow going this direction, and this another arrow going this direction. Now, the first arrow is saying that this is a solid, and when this solid, it melts. When heat is applied, it melts and become water. So when it changes to water, then another time from water, more heat is applied, it changes to gaseous form. Now, and somebody may ask, but sometimes we bring out water from the freezer and keep it on the table, we are not heating it. There is always a heat at any temperature. There is always a quantity of heat a body has at any given time. Even in the room temperature, when you bring it out of the freezer, the temperature in the freezer is different from the temperature in the outside. So the outside has more energy, more heat energy than the one inside the freezer. So when it mixes with the outside, it absorbs more energy, and the energy is absorbed is what makes the water to melt, the ice block to melt and become water. Now, it is going to be very difficult for just the room temperature to be able to heat it to this temperature of the gas. Rather, this is purely an application of heat. When heat is applied, it changes to gaseous form. However, there is another way which is called cooling. In that case, we have condensation. When it condenses, gas will condense and turns to water or liquid. I'm using water because it's a universal solvent or universal substance, which everybody is using. Then liquid, when you take away heat from the liquid, it gets cooler and cooler and cooler. The more heat is taken away from the liquid, the more it becomes solidified, and that is called freezing. It goes back to this thing. So these are what heat does. So heat is very important branch or aspect of our life. Another one is change in temperature. When we are talking about change in temperature, we are saying that, yes, we talk about heat, and some people look at heat as temperature. They are not the same. Heat is quite different from temperature. However, increase in heat leads to increase in temperature. So they have, it's like a twin concept. So you can't talk about heat without talking about temperature. So the only thing we are talking about here is that whenever there is more heat to a body, this is what you are going to see. What? Increase in temperature. So the temperature starts from wherever it is and rises to a point. And temperature is the degree or the degree of coldness or hotness of a body. And this is really a very conventional definition. We can say, personally, I prefer to say that temperature is the average kinetic energy of the substance of a substance, or average kinetic energy of the molecules of a substance. So that is what temperature is. However, I can say that heat is the total internal energy of the body. A video has been done on these two concepts, but they are not the same as a physicist, so you have to know that. Then another one is change in the physical property. Look at what you are seeing there. If a body is heated, it changes in the physical property. The physical property can be anything. It can be the shape, it can be the color, and any other thing that explains the beauty or the physical of a substance. For example, most of these plastic buckets, we know that it changes color after a long time, especially by pouring more hot water inside it. It changes the color because that's heat. So if you want the bucket to change color, keep on pouring hot water directly to it, because that's what heat does. It changes the physical state of a property. Also, when you heat a metal, like you are seeing, and that is why you can see a metal turn into different shapes. Some can be a ring, some can be a knife or whatever. That is because heat is applied to it. Now, let's go to the next one when we talk about kinetic molecular theory. Kinetic molecular theory, that means we are looking at the building block of every substance. Every substance has building block. For example, if you have this as, okay, let me put it this way, make it a little better. If you look at this, can be a box, and this box is not alone. Inside it, there are a lot of things you can't see. Inside it, there are a lot of things we can't see. And all these things you can see, they are the molecules or the particles that make up the whole substance you see. Whatever you see, they are all there. So now, those things, we look at them as molecules or particles. Now, the theory assumes that matter is made up of atoms and molecules. Now, the question should be, what is atom? They say that, remember, atom was first talked about by Democritus. Democritus was the first man to talk about atom, but at the time, he was not, the concept of atom was not believed when he said that there is an indivisible portion of a substance, a very tiny portion of a substance that can never be further divided. And at that point, they didn't believe him. Then after so many years, maybe because of the presence of Aristotle at that point, when Aristotle was a man, was highly respected because people thought he was the most learned at the time, and his interference on that theory didn't allow the theory to go further. But after many years, many other scientists came up to say, yes, there is this smallest part of a substance which can neither be divided. So they call it atom. So we say that atom is the smallest part of an element which take part in chemical reaction. So we also say that molecule can be the smallest part of an element which can exist alone and still take part and still retain the properties of that substance. He said that molecule is the smallest part of an element which exists alone and still take part and still retain the properties of a substance and can also be part of any chemical reaction. For example, when we talk about atom, we can say that this is an atom of hydrogen. This is a hydrogen atom, but this, when we have this, we say that this is a molecule, because this is a hydrogen molecule. So when they are one, we just call them atom, like this, an atom of chlorine. But then when it is now two, and we say that they can exist alone. That is what we say that they can exist alone and then take part in chemical reaction and also retain the chemical properties of that element, the chemical properties of the element of the chlorine, and so other things. So these are the things that make up the substance of matter, or everything that you see. Now, kinetic molecular theory. When we talk about this kinetic molecular theory, we are talking about the heat effect in the assumptions of a matter. Now, the first thing they talked about is that every substance is made up of tiny particles called molecules, which we have just said. So whenever you look at every substance, according to the kinetic theory, that every substance has a very tiny substance, and that tiny substance is called molecule. Now, number two, they said that the molecules are in a constant state of random motion, colliding elastically with one another and changing their direction as a result. Now, it doesn't matter. We have done this in series of videos. You can even go check our video on matter. You will see more of this. But however, we want to concentrate on this as a factor of heat. Now, when we say that molecules are in random motion, every substance you see, be it your phone you are using, the laptop, the food, plastic, anything, there is something inside it which is always in constant motion. If it is in solid state, the vibration is constant, just going up and down motion at that point. If it is in liquid form, the vibration is not as fast as compared to that of a solid. And when it gets to gaseous form, the vibration is way more rapid. This is to say that there is something common or similar between solid, liquid, and gas of any substance. And that is the fact that the molecules of these substances in their different states have a constant molecule, that the molecules are in constant motion and it never stops. However, what happens is that the application of heat increases the rate of vibration of those molecules. And that is why they change from one state to the other. And then number 3, we talked about there is always an attractive force between the molecules. So there is always a force of attraction that hold each of these molecules down, that keep them bound, that doesn't allow them to move out. However, more heat application to the substance can break that the energy holding them together, because the heat can give energy to the molecule. They gain the kinetic energy that will enable them to move faster, and in moving faster they break through from the force of attraction holding them down. However, according to the kinetic theory, that this force exists. However, the forces are stronger in solid, not as much as it were in liquid, and even less when it goes to gases. Now, the volume of a gas is negligible compared to the volume of the container. That means whenever you see a gas, that the volume of the gas takes the shape of the container. So if you see the shape of a container, you have seen the shape of the gas. So we don't really talk about the shape of a gas, rather we talk about the shape of its containing vessel. So wherever, if you put a gas in a circular rubber or in a spherical object, the gas will be given the shape of a spherical object. When you put the gas in a rectangle, in a cubic object, the gas will take the shape of the cubic object. These are few theories and assumptions and opinions to me about matter, and they are all related to heat. Now, there is another one which talk about average kinetic energy of its molecule. Now, we said that kinetic explanation of temperature. Now, when we talk about temperature, we said that temperature is the average kinetic energy of the molecules of the substance. Look at what I mean. Let's assume that this is a substance and then heat is applied. Now, these are all the molecules. Now, remember the average kinetic energy of each molecule, that is temperature. Temperature is the average kinetic energy of the molecules of the substance. Yes. Now, let's assume that these are the molecules. Then heat is applied. When heat is applied, what will happen to these substances? They will gain kinetic energy. Each of them, the ones here, they will all gain kinetic energy, and they start moving randomly and hitting the walls of the container. So, at that point, the energy has increased, and the velocity of the movement of each of these molecules has also increased. Now, each of these molecules will have its own energy. Let's assume that if the energy of one of these molecules is, let's say, 10 joules here, the ones here could be, let's say, 5 joules. The one here could be, let's say 3 joules of kinetic energy. So the kinetic energy of each of these molecules inside here, when you add all of them together, for example, you just want to take average. You know what I mean by average? So the average of each of them, if you add all of them and divide them by the number of the molecules here, the value you get, you will never get this 10, neither will you get this or this. You will get a new value, which is called the average kinetic energy of the substance here. Now, according to the kinetic theory is saying that that the individual molecule, the velocity of the individual molecule, or the kinetic energy of the individual molecule of any substance, its average corresponds to the temperature of the substance. That means the higher the kinetic energy, the average kinetic energy of the molecules of this substance are increasing, the more the temperature is going to be increasing. Now, there is a statistical mechanics, there is a branch of physics we call statistical mechanics. This branch of physics, they look at a substance and they know that in any substance there are a lot of molecules. So they use probability concept to study them, because every substance is made up of uncountable number of molecules. So just like we have individuals in a community, we have human beings everywhere, that taking the population, we also say that we can also take the population of the molecules of a substance. To me, it's just using statistics to explain the concept of a substance according to its particles. Like I said before, there are many particles that scientists have not come. Some of these things are just assumption and personal explanation to explain something which have been consistent in its happening or in its occurrence. And that is why all these theories have remained up till now. So when we talk about the average kinetic energy, you know that is about statistics. So that is what temperature is all about, the average kinetic energy of the molecules of a substance. Thank you for being part of this class. Remember, before we go, we have to go down to Examguide app and take a few more exercises that will help you. Now let's use UTME. Oh, we have 3 questions here. So we have the first question, thermal equilibrium between two objects. So this is UTME. They say that thermal equilibrium between two objects exists when A, the temperature of both objects are equal, the quantity of heat in both objects is the same, the heat capacities of both objects are the same, D, one object loses heat continuously to the other. Okay, thermal equilibrium. Let's talk about this a little. So when we talk about thermal equilibrium, we are saying that there is a body called body A, and then let me put another body here, body B. Now, heat will continue to flow from body A to body B if body A has, let's say, 50 degrees Celsius and B has 30 degrees Celsius. Everything that happens here is the fact that there is difference in temperature. That the temperature here is higher and the temperature here is lower. Then what will happen? Heat will flow. And that is why heat is defined as a form of energy which is on transit or which is always moving as a result of difference in temperature from a hotter body to a cooler body. So because there is a difference in temperature, heat will flow from 50 degrees Celsius, that's from body A to body B, until probably after exchanging heat for some time, then this will gain, then the two of them will now have, let's say, this one will lose and become, let's say, 30 degrees, and then this one will become, so the two of them 80. So this will be 40, and this will be 40 degrees Celsius, 40 degrees Celsius. Now, when the two of them become the same temperature, we said that thermal equilibrium has occurred. Therefore, the temperature of both objects are equal. So when this temperature of the two of them become equal, then we said that thermal equilibrium is reached. So option A is correct. So let's go to option B. The severed wall inside a vacuum flask is to prevent heat loss by severed surface. When we talk about severed surface, we are talking about a surface that does not attract heat. I mean, not attract, that its emission of heat is reduced. Therefore, it should be a radiation. Good, it should be a radiation. It can be conduction, it can be convection, it can be evaporation. It is radiation. So severed surface is to reduce heat loss. Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that makes learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the video to people that will benefit from it. Bye.